Greetings! In this video, we will explore how LLM agents integrated in your IDE can enhance the software development process. We'll discuss what agents are, their benefits, and why they have become essential tools in modern development environments. During the hands-on session, we'll demonstrate how to use these agents within an agent framework to create a project from scratch. When ChatGPT was first introduced, developers found it quite useful for writing code. When copying the code from IDE to browser, LLM could review and even help you improve it. But that required you to switch between windows. So to address this issue, LLM extensions were added to IDEs. An example of such a solution is GitHub Copilot extension for Visual Studio Code. It offered context-based prepopulation, dialogues via commands, and suggesting code solutions, such as writing functions based on their name. Next, organizations developed dedicated IDEs that offered various LLM-based features. For example, the Cursor IDE offered sophisticated features, such as interactive terminal on behalf of the LLM and various LLM model access. It seems that the LLM integration has reached its limits, and there are no ways to make it even better. But there is still something to improve. And this improvement is not about just some new features or tools. It's much deeper and involves changes in methodology. Look at these two prompts and try to answer these questions. Who wrote these prompts? And which prompt is more likely to give better results? You can pause the video for 10 seconds and think, but it's rather obvious that the first prompt was written by a person who is not so good at web programming, while the second one was written by an experienced web programmer. Regarding the results, the second prompt will also give you better results. So the problem is not in prompting skills, although it matters as well. The key difference here is that this detailed prompt better describes technical details of the solution, which allows us to steer the LLM to the correct context. An important note about this is the more experienced you are, the higher the chance that you will be satisfied with the obtained result, since you can more clearly describe your technical requirements. The same applies to result evaluation. An experienced person is more likely to notice issues in the LLM's output due to their deeper expertise. The idea of this new method is to transfer knowledge to other people, allowing them to create more sophisticated prompts. The solution is agents. After all these reflections, we can conclude that agents are essentially experience plus prompting. Best practices, quality standards, and other things are transferred to LLMs via system prompts, which are also considered when LLMs get requests from users. Agents reflect experience that people gained when doing their responsibilities. For example, best practices of solution architects allows us to consider such criteria as technical debt, scalability, security, observability, etc. These criteria will also be applied to the LLM's output. Now let's proceed with the hands-on session. In this demo, we will open the Greenfield project, install the KubeRocketAI agents that come out of the box, and call a number of them to create a to-do app from scratch. We will use Cursor as integrated development environment, but this procedure applies to any IDE that has LLM integration. First, open the project in the IDE where you want to create an application. Next, open the built-in terminal to add KubeRocketAI agents. An important note: if you don't have the KubeRocketAI framework installed yet, you can read elementary instructions on the GitHub page. Installation comes down to running a couple of commands depending on the operating system, and that's it. See the link to the repository in the description below. Now, getting back to agents. In the terminal, run the krci.ai command to install agents in this project. It will create folders that will contain agents, so we will be able to call agents from this project. Consider this action similar to git init or terraform init, for example, where you also initiate projects in your local environment for working with these tools. Since I work in Cursor, I can ask it to install the agents for Cursor integration. To install agents for Cursor integration, I need to run the krci.ai install command with the IDE option for my environment. Okay, as we see, the output states that the agents have successfully been installed. Indeed, we can see that a number of hidden folders appeared, including .krci.ai and .cursor. If we hadn't specified the IDE option, it would have installed only core components of the framework. When we install the framework specifying the IDE, it creates an additional folder. In our example, it's .cursor. This simplifies the process of calling agents. Now, I can call them by simply using the /agent name in the chat. Let's see what agents we have using the krci list agents command. Okay, so now that we have agents added to the project, let's try to call one. May it be a product manager. Call it using /pm. As we see, it called the PM agent and it responded according to the output. Now we know that this agent has a set of tasks, such as create project brief. Let's look at the tasks file. Most day-to-day tasks can be split into small repeatable steps. This systematic approach allows us to create a task and give it to LLMs. When this task is mentioned in the prompt, the LLM will follow this task structure when generating an answer. So, okay, let's ask the agent to create a project brief for our to-do application. We've prepared a prompt that we will just copy-paste in the chat. I want to create a simple to-do app, something where users can add tasks, mark them complete and delete them. Make it web-based so I can show it to people. That should be sufficient. Okay, here we go. As a result, the product manager designed the core criteria and requirements for the to-do project. The output is saved to the designated folder, as described in the task conditions. Now, let's design software architecture for the application. Let's call the architect agent. We already know that the architect agent has the create SAD task. So we will run this task from the architect to create a solution architecture document. This task contains mentions of all the aspects of the solution the architect considers when designing architecture for a new product. Let's write a prompt to the agent. Based on the project brief, design the system architecture for this to-do app. I wish I could build it and run locally. Refer to the docs folder for more context about the application. Since we use several agents to create a solution, it would be important to know that there is a folder with the requirements. Alright, here we go. We will fast forward the process to save your time. Now it created another folder within Docs. It contains solution architecture documents that resemble common SADs. We came to the final prompt, which will be addressed to the developer agent. This agent has the implement task. We will use it to create the application. Please implement the to-do app based on the data provided in the docs folder. I need working code that I can run on my MacBook. Run the application and give me the endpoint when you are done. Okay, here we go. Now that the developer created and verified the application, it is time to view the result. The agent launched the to-do app, so let's have a look at it. As we can see, it has a nice design. Let's test its functionality by adding an item. Okay, great. We see that it works. Now let's remove the item from the list. Item removal works as well. Guess we can call it a day. In this video, we explored how AI agents encapsulate expert knowledge and best practices to improve development with LLMs in modern IDEs. We demonstrated how the KubeRocketAI framework allows you to leverage specialized agents for different roles, namely project manager, architect, and developer. With the help of these agents, we built a complete To-Do application from scratch in minutes. This approach is especially valuable for small teams and greenfield projects. If you're interested in trying KubeRocketAI, check out the GitHub repository linked in the description below. Thank you for watching.